Now, in this video, we are going to take our difference quotient from the last video, and we are going to use that on an example here. So we are going to find the slope of the tangent line to f of x equals 48x minus 16x squared at the point where x equals 2. And this is something like we did in the last chapter, so again, a little bit of a recap here. But we can put a slightly new spin on it. Rather than calculating the secant slope formula first and then just replacing h with 0, we can set it up straight from the beginning as a limit as h approaches 0 to find that tangent line slope. Okay, so that's what we're going to do. We're going to say the slope of the tangent line is, and let me just recopy that difference quotient formula for us. Limit as h approaches 0, f of x naught plus h minus f of x naught all over h. Okay, and we are going to put in, first of all, our x naught value, because that is the one x value that we want to focus on here. So it's this guy. This is x naught equals 2. And so let's put that in. Limit as h approaches 0, f of 2 plus h minus f of 2 over h. And so now comes the part where we're going to plug stuff into our function. Use that f of x there. This will look pretty familiar. Remember to keep writing that limit. We haven't plugged anything in yet for h. So f of 2 plus h here. Take 2 plus h and plug it in for x right there and right there. All right. So we will have 48 times 2 plus h minus 16 2 plus h squared, and that would be f of 2 plus h, and then minus f of 2, so we'll need that as well. 48 times 2 minus 16 times 2 squared. All right, all over h. So that might have exploded a little bit, but we're going to simplify things now. Okay, so we've got the limit as h approaches 0. And let's do a little bit of distribution here. We got 96 plus 48h. And then I'm going to distribute out that 2 plus h squared. That would make 4 plus 4h plus h squared. Okay. And then minus, in here we'd have 96 minus 16 times 4. Oh, which we could just do that. 16 times 4 is 64. There we go. Okay. All over h. And keep crunching it down. Limit h approaches 0. We got 96 plus 48h. Now we've got minus 64 minus 64h minus 16h squared. And then minus 96 and plus 64. Oh, all over h. Got a little too excited there almost, because you can see there's some really cool cancellation that's going to happen as usual. Look, our 96s are gone, our 64s are gone, and the rest we can combine some like terms with the h's there. And we would have limits as h approaches 0. That would be, what do we have total? Negative 16h minus 16h squared all over h. And you know what we're going to do next there? We're going to do some factoring and canceling, because we can certainly take an h out of both terms on top and a negative 16 as well if you want. So negative 16h, 1 minus h over h. Okay. And then, yes, the h's are going to cancel for us, and that's great. That's really what we're hoping for in these. We want that h in the denominator to cancel out, because that's what's stopping us from using direct substitution. So yeah, that's a good sign that we're on the right track. Okay, and now we've got negative 16 times 1 minus h. And as mentioned, we can direct substitute. So you can stop writing limit now. Negative 16 times 1 minus 0 for h, and that would just be negative 16. And so that is our answer for the slope of the tangent line. So a little recap for you, but now we've addressed it straight and directly as a limit for that tangent slope. So tangent slope is the limit as h approaches 0 of that difference quotient expression.